I'm stalking you again.
Hello. We are getting into it. It's picking up a lot of loose ends when Dave and Red were here. Remember, we built the floors for this, but took them back out because we had a lot of stuff going on. All these little imperfections where the prior owner had put in these ugly seat mounts. So we got a lot of stuff we got to grind off, trimming back all the rust. And then I'm going to clean and finish all this business before we put the floor caps back in. So you can see here, especially all those loose ends that were really rough and torch cut and they're rusted. Just working on detailing all that stuff out. So a good wire wheel, and then we'll put this rust inhibitive product on it. And that's a big mess, and it's very loud, and it's not very interesting. So I thought, instead of doing something that's not very interesting, let's try something that's interesting. On one of the prior episodes, we got into cutting those floors away and fitting the exhaust manifolds. When I got them from Tom, he said, the exhaust manifold is cracked. Totally usable, but cracked. Let's explore. Now for today, we're going to try a little format change. Nothing major, but we're trying to reduce the amount of editing and finish work so we could show you more videos. In other words, instead of Jamie sitting there for 8 hours doing all the thing, we're going to try to bang these out. Just an experiment. We're going to see if we all like it or not.
Well, and we're really excited too because 2025, new energy. We want to get these projects moving and out of here so we can bring in some new cool stuff, namely
Ian Roussel.
my Jeep.
Oh, the Jeep.
And Lil Jewel. And do you want to talk about that? About tomorrow?
Well, we have
Or
a very
about our
special
live that we did?
announcement. If you're following us on our Facebook group, you'll know the insidious Ian Roussel. So we're doing a tribute to the great Ian Roussel.
It's going to be in our merch store.
That's tomorrow's story.
So excited.
Yeah. Check out this exhaust manifold. I did a little looky-seeing, and I hope the camera can pick it up. You see this line?
Yes.
See how it comes through here?
Mm-hmm.
That's a crack. That is an exhaust leak. So, look, you can really see it good in this light.
Mm-hmm.
See how it comes all the way up through?
Yes.
That's, it happens. It happens. You'll see it a lot in these cast manifolds. And I was getting some critiques when I was putting these on because some folks were saying, that's why I don't use cast iron manifolds. They don't make power. I don't like the way they sound. This bolt is bent.
Wow.
So, I mean, yeah, it's a used part. Do I think it's still totally usable? Yeah. I like cast iron manifolds because they're quiet. This isn't a hot rod. It's not a performance vehicle. Headers give you that ping, ping, ping sound, and they seem to me like they radiate a heck of a lot of heat. Whereas these, they get hot, of course. It's not the same vibe. And I feel like it muffles the sound better. That's what we're looking for, quiet cruiser.
Quiet Cruiser. That might be its name. Oh my goodness. Quiet Cruiser.
So we're going to get in and we're going to repair this. There's two ways you can repair cast iron. That's what this is. You can weld it with nickel. It's like a nickel alloy rod, arc weld it. I bet you could even TIG it with that. Or you can braze it, and that's what we're going to do. We brazed once before, very thin metal, very thin sheet metal to copper. We brazed that on a fuel tank for the mini trike. This is a very thick casting, so this is cast iron. Same process, a little bit different treatment of the heat and the prep. So this has probably got a lot of carbon, a lot of impurities. So we're gonna have to bevel this out. We're gonna have to open this crack way up and get it as clean as possible. Yep. We're gonna have to open up the crack and get it as clean as possible. Dad jokes. I'm gonna do that with a cutting disc on the grinder and probably the air tool in here. So I'm gonna get Jamie's protective equipment in place, and we'll get to getting.
I just want to say I'm really, really, really excited about Ian Roussel Monster.
Me too.
I'm so stoked. Like, I almost want to get this video up today. So, yeah.
They know.
So everyone knows. Like, oh my gosh, I'm so excited.
I'm going to wear my spectacles. It's not going to be a very long video either. So if there is no edit, we could probably just post it today. Cool. So I'm going to start by beveling this out. It's going to be loud. We're not editing the volume, so stick with us.
I do like that you're giving the disclaimer, so then if you are wearing headphones, just turn it down.
So what I've done here is I've cut all the way through. I wish I could put a light in there. It might help if I do. So this is an interesting format because it's sort of like a live, but it's not actually live. It's us. This is us taping live before. No, it's like Happy Days. Yeah,
like a live studio audience. I should get like a sound maker thing that I just press that has like the laugh and the clap.
Yeah, so the light will not transfer into that. Oh yeah, there it is. See the light in there?
Yeah.
So I've cut all the way through that crack. So with welding, there's the term full penetration. Well, you want the weld all the way through. We're going to want that with the braze. So that's why I'm preparing a root gap through the crack. That way that material, the brass or bronze or whatever alloy, goes all the way in. I'm going to cut again. I'm going to put the larger diameter disc on because I got to reach. This is hazardous. I'm not going to break the disc because I'm experienced, but you should be very careful should you try this. I need to really reach, so I'm going for the full brand new 6-inch disc with the most bang for the buck so I can get in there. Still not enough. Try it this way. Nope. Get as much as we can. All right, so that's as much as I can get with this. I'm going to grab the die grinder with the air tool. All right.
What? I left on my PPE.
This is going to be a little loud, so I'm glad you did.
And those of you that are looking for these, I believe George is now shipping and selling. So www.imuffs.com.
Now, I don't talk too much about these, but I have used them a lot in the past. I recommend everyone gets one. This is a really low-priced thing. You can get them at like Harbor Freight. A lot of them are slow, which is a bummer. This one happens to be quite fast. I don't know what name brand that is, but I like them to run pretty quick. And then these are available online as well. It's a carbide burr. That's what we're going to clean this up with. They have electric ones of these also. Just going to run this right here and open it up. See how much easier the cast iron cuts than actual steel? It's a reasonably soft material. You know what I did just before we started recording?
Go to the bathroom? Okay.
No, I did that, but I also shut the air compressor off. So I'm going to turn it back on. We're going to have some noise. I'm gonna let that air pressure build up a little in the tank because we're starting to run out. I'm just gonna clean up around the sides of this repair. The cylinder heads on the engine are machined flat. That's why these surfaces look nice and flat. You hear me say a lot with sheet metal about warping. We'll have the potential to warp this entire manifold because as this cools, it's going to contract. So we're going to need to clamp this to something very strong. I'm going to try to clamp this to this square pipe, or tube as it were. You know, even though the terms are interchangeable, technically they're not. So we're going to do the whole process clamped to this, or the table over there, because we want all these surfaces to stay straight. So I was going to clamp that manifold to the big heavy table, but I realized we wouldn't have the opportunity to flip it. We're going to need to rotate it. Looks like we can get a good grab on here. And, you know, this pipe is not unbendable, tube rather. It's not unbendable, but I've done this a bunch and I've been successful every time. So I feel like this looks like about a 3/16 or 1/8 wall, 1.5 inch or so tube. It's actually the stuff they make trailer hitches out of, so reasonably strong. Cool. All right.
Wow.
I know. I know. When you said, "Oh, we're going to learn to braze again," I was like, "Yeah, but this is a different animal." All right. So, as with the other brazing procedure, we're going to need to get this very hot with the oxyacetylene torch. We'll do it over here on this heavy bench. I was going to clamp it to this. See how strong that is? Mm-hmm. But we wouldn't be able to rotate it.
Bummer.
We're going to set up like this first. And we're going to try to work it into that root gap first. And then I'm going to try to build a bead, a little reinforcement over it too. So we're going to get this set up on a little jig. What'll work? Little piece of Volkswagen every time. Let me set up the torch. All right, so this is not arc welding, electric arc welding, so shade glasses, just like you would use for cutting, are appropriate here. And Jamie won't need a helmet or anything because it's a flame. It's a lot gentler. All right, let me take one more wind off of this.
I'm also looking through the camera and standing far away and
Yeah,
zooming in.
You know, some smoke and a little bit of spark possibly, but cast iron's pretty mellow to work with. All right, so we're gonna get a pretty good flame with the tank. With the thin metal, we didn't need very much flame, but this we want to get red hot. Neutral flame, like we always use. Just gonna get this red hot. See, it's cooking out some of the little shavings, maybe some impurities. The hotter it gets, the better. And we get a lot of people who comment on our videos and watch them who don't even know about cars or repairs or anything. So that's why I thought this is a valid lesson.
Right?
You see how thick it is in the casting here? See how that's staying dark? That's, wow, that was cool. See the backfire?
Mm-hmm.
So that's the thing with brazing. You got to get the whole area hot. Otherwise, this will never go into the dark area. Ah, that was cool. Let's see if we can do it again. I don't know how we made that happen, but we did. All right, so deep down in there, it's starting to get red. I'm going to work on this area. All right, now we have the brazing rod. The white material on it is a flux. That's what allows the metals to come together harmoniously. Yes, it. Ooh. See, now the brass is going in. Let that shut down for a second. Now we're going to turn this heat down a bit. And we're going to do a more controlled application because we got that brass all the way down inside. See, now we're just working it sort of like a weld bead. Just drop, drop. All right, let that cool a bit. Come in and do another pass. Yeah.
Very soothing.
Yeah, I did a lot of lead work on copper gutters and stuff, so I learned this. It's sort of a welding technique in where you're creating a bead, but it's not welding. See how it gets a little fussy sometimes? Mm-hmm. You got to work through that. So see this area where it's not really sticking right there? Mm-hmm. I'm going to try to get that to close up. If it doesn't go through the heat, if it doesn't doesn't close up during the heat, then we're going to have to clean it. That's some impurities. Let's put a little flux on there. Stir it in. There, it just went. Cool. That's why I was cleaning it the way I was. Cool. Now we're just, so we got this hollow here. Let's try to build that up. Setting it on top. Starting to get a little heat on my fingers. Yeah, cool. Build that up. Let's come back in here. Drop some on top. You see this little, oh, it just joined. Sometimes you get a little cast off pellet. You have to clean it up later. But in this case, it just fell right in. Yeah, this is working out nice. Cool. All right, so this brazing rod is almost over. Congeal. Let that cool down. So the whole repair, see, it's raised up. That's what I was getting at earlier. If it sinks as it cools, we can apply a little bit more. But we're going to let that set for a moment. Then we're going to do the top side.
So with that being so hot, it's not going to fall out the other side when you turned it upside down?
It could. Good point. That's the idea of the controlled heat. Got torch. Got to have that torch hand ready. So if you heated the whole thing up red, it would probably just slurp right out the bottom.
That's what I was asking. Yeah.
Definitely. Let me get a wire brush. So with soldering and brazing, that's very much an issue. With welding, the temperature is really hot, so you don't typically
Have to worry about it.
run into the same pitfalls. Yeah. So I've worked at some shops where they'll just throw away the stubs of the pieces they were using, especially TIG shops. But me, I'll just put them back together. So this little stub here, I'm just going to attach it to this.
It's like a magic wand.
A little bit. Going back in. See, I'm moving the heat over here. I'm probably going to work towards that, because that other repair is still quite warm. See how easy it got red? So we got to get this whole action heated up. We might get some backfires too, so keep an eye on the back end. That's the gas going in through the little crevice and igniting. It is literally a backfire. All right, it's getting there. We want it hot, but not so hot that the cast iron actually disappears. So give that a try. There it goes. We got a lot of velocity in the gas coming out of this torch. It's starting to blow that material around. Now that we're hot, I'm going to calm that down a little bit. I'm going to try to just get it to all fall into place. See how sharp the shape is where it cools off? It's like a sharp wave and not just a puddle. That means it was not very, very hot. It just got blown into place by the gas.
This is a little bit scary.
Yeah. If the torch backfires, it'll be real exciting. Yeah, cool. Now I'm just going to work on burning away this rod and puddling up the brass or bronze or whatever this stuff is. I think brazing rod is a brass or bronze alloy. It's starting to get a little warm in the finger. Yeah, cool. That's perfect. So you hear that weird little squeaky sound?
It's not a mouse?
Definitely not a mouse. It's just interesting. When I learned gas welding, the room would be silent. And you just hear squeak, squeak, squeak. All the students doing this. All right, cool. It's probably going to spill over the edge. I don't mind that because we'll just sand that off. Yeah, that's a nice hot drop of material into there. Might hit it once more. Cool, yeah, there we go. It's interesting, once you hit the right temperature, it just turned into a nice controllable puddle. You'll see how I'm stirring it with the torch. That's because occasionally these little voids will appear. And then the flux falls in, makes them join again. Yeah, it looks nice. So that's a little more support than the original casting offered. See through here, there's a pretty good swoop. That's a little bit built up. So we'll let that cool 100% to room temperature. And if we're working and we hear tink, that means we're going to have to redo it because it's separated. It'll be much less of an exhaust leak than it ever was, should it crack, but we're going to want to remedy that. And also, we're going to remedy that bent bolt, and we're going to work on this too. This is a oxygen sensor, so this is probably a fuel injected or something similar. It's pretty early form of fuel injection for whatever year this was from. Could be a throttle body, but there's only a sensor in one manifold. I digress. So this bent bolt, that's a problem. That's something you will see eternally. So we're going to heat this whole nub. I'm not worried about this part warping because we're not adding any material to make it contract. We're going to try to superheat all this and get that to unthread. Very common exhaust problem.
So I was just asking Ian, I wonder if I put sunglasses in front, if you guys could see it better. And then he said...
It's fairly difficult to see what you're doing, especially when you're arc welding with the big helmet on. I know what I'm looking at, so it's a little...
Okay. I wanted to make sure I wasn't missing something in filming this for everyone. Okay, cool.
No, the process is most important in the end result. So if you were to step back and you see something similar to that, a nice lake of molten liquid, that's what you're going for.
Cool. Thank you for clearing that up.
There are no stupid questions, only stupid teachers. Now we're going to work on getting this whole thing tidied up. If this bolt does ultimately break off, we're going to have to drill and renew it because this is a steel bolt and a cast iron manifold. I think we'll get it. The whole thing with this type of process is patience. If you rush it, you're going to snap that stud right off. There's a really thick chunk. You can see it's almost an inch thick across there. It's going to take some heat. The bolt's starting to get red though. So whatever crust or rust that's in there, we're hoping that these excessive temperatures will sort of loosen it up. Because the engine would, under normal operating temperatures, would never turn this red. Yeah, we're getting there. We don't really want the stud red per se, because that will weaken that with it being prone to breaking off. We're trying to get the manifold super hot. And the stud is going to get red, but trying to keep that the coolest part of the equation. Well, let's take the easy way out. We're not super hot, but this might free it up. So we're going to just give that a good clamp. Oh, look at that. So that was locked down so tight with the corrosion. We didn't even have a chance. That's why it was bent. That was me trying to get rid of it.
Whoa.
We got it. So we could thread a new bolt right in there.
Yay.
So whatever you do, don't touch that thing.
No.
It's hot.
That looks scary.
So while that's cooling down, let's walk over here and give this one an inspection. Tell me if you see any cracks in that, because I didn't first time around. Put on my very magnifying glasses. No, I don't see no crack. Nope, this one's good. Wire brush to double that up. A lot of times I won't wire brush it at first because you see the crack a lot better if it's dirty. Yeah, it's fine. Cool. So I'll just send these and get a decent bead blast on them. And we're just going to paint them with heat paint. We're not powder coating or anything excessive. No, it looks good. Cool.
And why is that? Why aren't you going to do the thing you just mentioned?
Money, honey.
Well,
it's expansive.
And is it more prone to like rust? If
the powder coating will make it 100%, or heat coat, whatever, you know.
With this car, we plan on having live in the desert. So.
And this is from the 1980s, and it's only this rusty. I could live with that.
Ah, that's true.
Clean black, you know, barbecue grill paint. I use that all the time on exhaust because you can touch it up. It's in a spray can. It lasts and lasts and lasts. So yeah, this looks
DIY.
cool. I'm going to bring that manifold over here. We'll start to clean it up. It's definitely not to room temperature, so I got some gloves. But we're going to get into exploring how the flux remains. Ooh, you know what I just realized?
What?
I have a heat gun. Let's see how hot it is. So that repair, you can cook a steak with that.
What is that?
338.
Oh, wow.
Yeah, because that's 68 here. Still quite hot. Let's go. 343, 342. What you don't want to do is put water on this because that could cause it to crack also.
And touch it.
Definitely don't want to touch it. All right, so I bet the flux is still pretty soft. This will turn to like a plastic crust that'll snap off. This is a good example of slag. Have you ever seen a hammer like this? Chipping hammer, a slag hammer?
Yes.
You've seen it because it's been here.
Oh, that's true.
These typically have a point on the end, but I was using it for a planishing hammer. But yeah, that's when you arc weld, it leaves the same sort of thing. But still quite warm. See, that stuff will just chip off. But I'm gonna get in there with the grinder and clean it up. I think at about 190 I can take this brace off. The engine will run at 180 in the water, so in the water jacket. So 190 at exhaust temperatures, minimal. Cool. So that's that. Lastly, still don't want to touch this. Try to get this pesky thing out. See if I have a ratchet. If I could take the air ratchet and just blast that out. Otherwise, we're gonna have to, oh, look at that.
This thing likes you today.
That's California cars for you. They get the rust. I was gonna braze that shut. Instead, I'm gonna go get I might even have a plug. Thread a plug right in there and jam it shut. Yeah, this is a pipe thread. I don't know if that's a finer thread. You like brazing that shut?
Sure.
Heck yeah. I'm gonna clean this up with the air tool. We're gonna learn how to fill a hole. No, this is a pretty advanced thing. That's a big hole to fill. You could drop a piece of brass in there to start it, but we're going to go around and around and show you how to fill that. We got all the bevel that we need. That means it's ground in. We took the threads off. So let's put it on that bench and we'll work around and show you how to fill it. So the only difference with this as opposed to that is we don't really need the penetration that we set that up for. This is just a cap to stop the exhaust from coming out. So we just want to grab, see where I cleaned the edges and beveled it. We want to kind of just start building off of that right into the center without having it fall through. It's a little bit of a dance. Keep the flame a little bit lower so you don't have that thrust that blew all the material around when it was liquid. And at this point, we're just going to get one red spot. We don't want to superheat the whole thing because that'll cause it to fall through. We want to dance right on the edge of a liquid, hot magma. So see, we're getting a red spot right there. As soon as that grabs it, we're going to move. Grabs, move. And some will fall through. This is not a perfect science at this point. See, we're just attaching. And you can see I'm putting the heat outside of the hole. Because if we put it in, it's going to fall right through. And right as we get to the last point will be the most critical. That's when you're literally floating liquid metal through the gap. So you can see it crawl around. It starts to join. See, as soon as the temperature hits. I hit it with the flame and back off. Kind of like when I use the MIG welder and you hear me go tick, tick, tick as I'm dropping the metal. Mm-hmm. Same flow. Except it's not an electric arc, so you don't hear that on-off switch. You have to move the flame. Yeah, I'm starting to get a hot hand. I'll be right back. And if you put the heat on the rod, it's just going to burn back because it's a smaller piece of metal. The heat goes into it a lot easier. So you're keeping the heat on the large cast piece, and you're just adding this rod as you need it. So this is the same technique you'll see Gene Winfield or the old school guys use in gas welding their cars, but a much lighter torch tip and a little bit different technique because they're actually welding and not brazing. You see, you use the flame, you hit it, and you move. Cool. Just about shut. This is where I could do it really wrong and have it all fall through. But it's very hot now. Let it set back for a second, get that red out of it. Yeah, it's almost closed. Cool. There it is. I'll let that cool off for a second. Look for any holes and add a little more material uphill. Cool. Now, turn this heat up. Try to dress it a little bit. We can get rid of some of that blob look. It'll just look cleaner without having to grind it. So, get the heat on. I'm going to work the edge. As soon as that stuff starts to move around on its own, I'll pull back the heat and let it settle. Yeah, that thing shut off. Yeah. Cool. See how it's just dressing up to one nice little shape. It's wanting to fall through, I could see it. Trying to get that center to close up a little bit better. See that little shape at the center there?
Uh-huh.
That's going to give us trouble if we don't add some material right there. There it is. Cool. Yeah, I like it. Nice little button plug. And there's cool. There it is. Exhaust repair 101.